Good morning, everyone, and welcome to this poster which deals with a technique for the direct measurement of the junction temperature in power LEDs. I am Francesco Della Corte from the Mediterranea University of Reggio, Calabria, Italy. I believe that everyone remembers incandescent light bulbs, which in spite of their 15% efficiency, can be considered very reliable objects, working for years at several hundred degrees Celsius. They've been replaced by light-emitting diodes that are today the most efficient artificial light source. However, they are sensitive to temperature, and operating an LED at 100 degrees Celsius can cut lifetime by 50%. So LEDs need to stay cool. And in order to do so, we need to constantly check their fever. We can use an external sensor, but it is much better to measure the junction temperature. Over the years, our group gained a deep knowledge about a TGA measurement technique that consists in tracking the forward voltage drop at the PN junction while a constant current is applied. All you have to do is to characterize the device once and for all to get two parameters, S and Q, through which the junction temperature can be calculated once you measure the forward drop. We have generalized this method, allowing to run the TJ measurement at any current in a proper range. Here we show that this method can be implemented using an off-the-shelf LED driver, combined to a standard microcontroller which orchestrates all the routine and makes the necessary calculations. The block scheme is shown here. In normal operation, the driver sinks the LED on current, say 500 milliamps. At a given time, the microcontroller asks the LED driver to sink a much lower current for a short time. Forward voltage and current are carefully measured several times, and an exponential interpolation is done on this data to estimate the forward voltage at a precise forward current, where this equation provides the lowest error. This graph synthesizes the results we got with this circuit. Each dot represents the result of a measurement routine. We run 10 of them at each temperature in order to quantify the repeatability of the technique. Note that an error of a few degrees is widely acceptable for controlling an LED overheating, considering that we are measuring the true junction temperature, not its case temperature. Only when necessary, countermeasures can be taken to cool down the LED. Thank you for watching and feel free to ask more details.